It's my first video on YouTube. This is going to be a coding channel, where I'll just be coding random things. So to start off, I'm going to be using a Java-based language called processing. It's basically Java with some added stuff. But here are some examples of it. I'll be going through this pretty quickly. I'm not going to be doing much of a tutorial or any kind of tutorial series, so don't really expect that. I'm just going to be doing some random stuff in coding. So I'll be doing, making games, I'll be making just, challenges and whatever. So, and you can follow along too as I make it. So I just have a small example. So there's two special functions called setup and draw. So this will, these two functions are special functions. This will be called when you run the program, and then this will be called every frame. When you run it, it will create a window. To control the size of that window, use size and put how much pixels you want by how many pixels. So this is 900 by 900. So then in draw, to get a background, you can use background. You can put the RGB values, the grayscale values, or the RGBA values. So here I'm making it blue, because, yeah, it's green, what am I saying? And then to add things on there, there's special functions like rect and triangle and whatever to make different shapes. This is, just so you know, this is not only 2D, it's also 3D capabilities, but you have to put P3D there. So, and that will be able to make, then you'll be able to make 3D stuff. To outline, you can use stroke and put the RGB values. Also, to add no outline, you can use no stroke. Same with the fill. You can add no fill and make RGB values. So if I run this, then you will see. Oh, by the way, the rectangle, you can put a position of it, and then the width and the height. And you see, I got a rectangle at the position of 200, 200, with the width of 200 and height of 200. Pretty cool. But so the aim of the first few episodes, I'm not sure it's gonna be 3. I'm gonna make an Astroid game. Astroid is basically where you control your player with the mouse and then hit some button to shoot something at the asteroids. So let's say the biggest asteroid will split in, when you hit it, will split into smaller asteroids. So then it's split into smaller asteroids, which will then be exploded. And then your goal is to get rid of all the asteroids. Pretty simple. Get rid of all the asteroids without getting hit by an asteroid, too. So first, I'm going to be creating in this episode the player, where I can move around a triangle. I'll say size. I guess 900, 900. You can make the size whatever you want, really, but I recommend doing 900 because that's what I'm doing, so most things will be falling off what I'm doing. So, to create a triangle, use triangle, and then you can put the positions. So, it's going to seem a little weird, but I'm going to put it at the origin of 0, 0. Well, I'm going to actually put it at mouse, because I want to be moving around the triangle. Cut that out. Alright, so to create a triangle, you can use the function triangle. Basically, arguments are the first set of positions, the next set of positions, and the next set of positions. Basically 3 points that create a triangle. Because all a triangle is really just 3 points. So let's say I want to make it at 100, 100, and then I want to make it at, let's say, 150, 150, and then I want to make this one at 100, 150. Okay, so I'm going to make no stroke. I want to outline, and then I want fill of I guess I'll just do grayscale 140. That should be grayish color. Okay, run that. Oh, there we go. Oh, triangle. Really bad one. Yes, triangle. How about this? Let's move this over a bit. 125. And also, I just realized, let's make the background black. Background 0. So I'm using the grayscale values here, and the grayscale values that's 0. There we go. A triangle. So now we're obviously going to want this to move around, well, according to our mouse. So just very simply, we can use mouse X and mouse Y. So we can add mouse X to this. Actually, I know this didn't work in our chats before, but whatever. Try that, try that. So this is going to be moving it based on what the mouse position is. So each of the X and Y values will be offsetted by their thing. There we go. It's moving around the mouse, but obviously you can see it's not really on the mouse very much. It's quite far away. Reason being is that we're actually offsetting it when we're using this. So we can use if we just do this, we'll just get a big dot. We'll have a dot there. Everything's going to be the same thing. So what we need to do is, let's say this is our top point. So then we're going to have to add 25 to here, add 50 to here, then add 25 to here, actually subtract 25 from there, then add 50 there. So basically what I'm doing here is that the point at the top will be equal to the mouse X and the mouse Y, and then the mouse X. And then the next point, I'm offsetting the mouse X by 25. So what this will do is take the point of the mouse and then find and then put it at the X of 25 next to it, and then the Y 50 below it. So all it's really doing is, according to the mouse, it will place the points. There we go. And now it's right at the tip of the cursor. Now, so obviously, it's not really lifelike, because you can see that it's just following your mouse. It's going to be way too easy just like that. We're going to do something where instead it's going to follow the I'm going to have a little variable called player X and player Y. I'm going to set that to 0. Instead of using mouse X, you'll use player X and player Y. I really hope the part of the mouse and the offset makes sense to you. Sorry if it didn't. So what I want to do is slowly gravitate the player X and player Y towards the mouse X and mouse Y. So I quickly put in some variables right here: old X, old Y, easing, and easing, yeah. So old X will hold the old player X. And old Y will hold the old player Y. Easing will say how much time we'll get to easing into the mouse. I can also call this gravitation. You have 0 gravitation if it's 1, and a lot of gravitation if it's, and it won't gravitate at all if it's 0. So thanks to someone on the processing forums for it. It's called like Amnon dot something. I don't really know. I couldn't really say it. I'll put a link to that in the description. Oh fuck. I'll put a link to that in the description. So what I'm gonna do So I did get the formula for it right here. Probably should get a charger. Whatever, I'll get that later. So here's the formula for it. I'll just change variable. Change back to eating. So basically what I'm doing, I'm taking 1 minus eating, which is going to be 0.95 times the old y. So how much of the old y do you want to consider inside it, right? And then eating, just regular eating times the mouse y, mouse x thing for this. How much do you want the mouse x to be inside it? So if it's 0, then the old x takes over, meaning not to move at all. If it's 1, then the mouse x takes over, so it only gets that. So you can see it makes a nice effects right here. Nice effect. Okay, I'm back. I just got a charger plugged in. So I just left off this thing. So the last thing I want to do in this episode is make the triangle rotate to where the mouse is going to be. So before I start on that, I'm going to get a better strategy of getting the offset. So what I'm doing is that the top point would be where the player X and player Y is, and then the bottom 2 points would just be the offset of that. To do that, I'm going to use something, a special function called translate. So translate is basically, so 0, 0, or the origin, is going to be the top left corner. And that's where this thing is drawing. This is where the triangle is drawing from. Now, if I were to move that 0, 0, the origin, to the player X and player Y, then the origin would be player X, player Y, meaning that this is just simply 0. At this point, I can just do this, because I translated it to player X and player Y, meaning the origin is now player X and player Y, meaning that 0, 0 is player X and player Y. Now to do this, I have to use push matrix. So translate is using matrices. Uses matrices. So I have to use push matrix and pop matrix. So think of a list of matrices, and then you want to take one and then push it, and then you use that one, and then after you're done, you pop it, and then you're done with it. So you can think of it like that. So now if I run it, it should run exactly the same as last time. There we go. Exactly. So now what I want to do is I can now use another special matrix thing where a matrix function called rotate. This will rotate instead of rotating the obstacle itself, it will rotate the whole world. But really, you can think of it as rotating the triangle. So I'm going to be using 8 arctan. So I'm going to use arctan to get to the angle of the mouse. So I can use mouse x minus player x. So this will take in the opposite and the adjacent. So I'm going to of the triangle. And when I say triangle, I don't mean the player triangle. I mean paint now. So let's say I had this is where I am. This is me, a triangle. That's a great triangle. This is a triangle, let's say, and this is the mouse. So I'm going to construct a triangle, just like that. Oh, that's so bad. I'm going to construct a triangle, just like that. I'm so bad at this. No. Oh, no. I'm very bad at this. No. Okay, there we go. Pretend that's connected. Right, pretend that's connected. Oh my god, I don't even know what's going on at this point. Okay, there, that's my triangle. So this is my triangle. What I'm trying to do is figure out the angle right here. I'm so bad at drawing with the mouse. So to do that, I'm using arctan. So I know this place and this place. I probably shouldn't use that. I just use arrows. I know the opposite and adjacent, because that's basically how far it is y, and that's about how far it is x. So basically, all I gotta do is get the how far it is from the mouse x to the player x, and the mouse y to the player y, and then just put that into arctan. So then that should, when I run it, it should not work. So you see it's not really working out very well. Well, that's because when I'm using arctan, it's actually 180 degrees off. So simply what I have to do is add half pi. Half pi would give me 180 degrees, because pi would be 360 degrees. So then half pi would be 180 degrees. You can see that's inverted. Oh no. Something's wrong. Something very wrong. Okay, I'm back. I realized my problem. I have to use the adjacent first before the opposite. Sorry, opposite first before the adjacent. So now that should work. I'm gonna leave the half pi there because I'm pretty sure it's still offset. Yeah, there we go. We got the player. It works. So thank you for watching, and I'll see you in the next episode.